Hi everyone, Architecture and Operating Systems module, we are in week 5 and today I'm going to talk about adder and subtractor. The journey that we have gone through so far, first of all, and in week 1 we discussed binary number and why we need to use numbering system for computers. Then we discussed negative numbers, ones and twos complement. And in the last 2 weeks we discussed logical gates. And I told you that why we need to use these physical gates to be able to do the operations for adding or subtracting two numbers. Now, in this week, I'm going to combine all of them and show you how computer works in order to add or subtract two numbers. Let's start with addition. Look guys, I want to add two bits, A and B. I have 4 different permutations of them. Let's put them in a table. A, B, 0, 0, 0, 1, 1, 0, 1, 1. So, if I want to add them, 0 plus 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and I've got carry 1. For the others, there is no carry. So, it means that we have only for 1 plus 1, carry 1, and the summation is 0. The carry for the rest of the permutation and numbers are 0. How to translate that using the gates? That was one of the questions on the worksheet that I told you that I will explain later. Look guys, as you see here, if you want to add these two numbers, this is the summation of these two bits. What is that gate? What gate I can use to be able to perform this operation to get these values for adding two numbers? Yes, that's right. This is XOR gate. If you use XOR gate, 0, 0, 0, 0, 1, and 1, 0 is 1, 1, 1 is 0. What about this gate? It is 1 when only both of them are 1. The rest is 0. The only gate that we can use here is AND gate. When both values are 1, we get 1. The rest is 0. It means that if I combine AND and XOR gate, I can perform adding only 2 bits. Only 2 bits. So what I've got to do, A and B. If I want to add them, for getting the summation, I need to use XOR gate. It gives me the summation. For carry, I've got to have AND gate for them. If I combine these 2 gates, that's perfect. I can add 2 bits, also I get the carry. Is that complete? No, it's not still complete. Why? Because if I want to add these 2 numbers, look guys, 1 plus 1, 0, carry 1. Excellent. I can use these 2 gates, the combination of these 2 gates to do this operation, to get carry and also sum. But when it comes to the next bits, because I've got carry, the story is different. Not only I've got these 2 bits, A and B, to add, but also I've got this carry in. So as you see, this system is not complete. And because of that, we call it half adder. It can add 2 numbers, but it's not complete. We call it half adder. I can say this is A, B. I can make an integrated circuit and I call it half adder. Half adder gives me sum and carry. Here I can use half adder, but for the red one, I can't use this because I've got another input, which is a carry in. How to do this? Let's go back to this one. 1, 1 plus 0, 1. 0, carry 1. Here is half adder. What about the others? Look guys, if I want to add these numbers, I've got 1 carry in and 2 bits A and B. First of all, you need to add these 2 bits. It means that we need to have 1 half adder, first of all, to add these 2 bits. I need to have 1 half adder that I just explained you here. XOR gate for summation, AND gate for carry. When you add these 2, 1 plus 0 is 1. You've got to add it by the other carry that you have with this carry in. It means that if you have carry in from the previous bit, now you've got to add it with the summation of these two bits, with the summation of them. If you want to add them, again, you need another half adder. Summation of them added by the carry gives you the final summation that we have. What about carry? This bit, this half adder for the first one, you can have carry for this one. Also, for adding these two numbers, the output of these two, and also the carry in that you have from previous bit, if you have carry for any of these two operations, we should have a carry then. This is carry. Look, the carry of this, or adding these two, if you have carry, we should have carry. So it means that in any of these summations, adding the first A and B, and adding that with this with carry in, if you have carry, we need to have a carry. So it means that if any of these carries is 1, we should get 1. What is this gate? Yes, if I have an OR gate, in case of having carry for these two, or carry in plus the summation of the A and B, if in any of them we have carry out, it means that I have a carry out for all of them. So I use an OR gate to show them. There you go. This is carry. This circuit, if I have A and B and carry in, having 2 half adder and 1 OR gate to show the carry, we call it full adder. A full adder is made of 2 half adders and 1 OR gate. I can say and show you that for adding 3 bits, that one of them is carry in of the previous bit, what I can say that if it is A, if it is B, and if I have a carry in from previous bit, if I have a full adder, we call it full adder, I can do the operations. This is sum and this is carry out. This is carry out for the next bit. This is carry in and this is the carry out. Full adder, having 2 half adder, 1 OR gate can help us. For example, if I want to add 2 numbers with 4 bits, 1, 0, 1, 1, 0, 1, 0, 1. If I want to add 4 bits together, it means that I should have 4 full adders. I should have 4 full adders. Why? Because 0, 1 plus 1, 0, I have carry in. This carry out will be carrying for the next bit. 1 plus 1 plus 1, 3 bits, I need to have another full adder. So as you see, we have 4 full adders. To show it better, if I want to show it better, look guys, for adding this, what I need to have is something like this. I need to have, I need to have 4 full adders because I have, if it is A, and if it is B, this is A0, A1, A2, A3, B0, B1, B2, B3. I need to have full adders to be able to add them. One may ask, what is this C0? C0 for this situation, if you have carry in for the first bit, usually for adding 2 numbers, it's 0, not usually, always it's 0, because for these 2 bits, we don't have any carry in, so this is 0. So it gives the summation. This is the carry out, which act as a carry in for the next bit. So for adding 2 numbers, I can easily use these 4, for example, for these 4 bits adding, I can use these full adders, 4 of them together, to be able to add them. Okay, I hope that's clear so far. You can, and I recommend you to use logically and create actually these full adders and be able and show how we can add 2 numbers with 4 bits. But But this is not the end of the story. And I want to discuss how we can subtract two numbers. Subtraction. So in subtraction, as I told you before, what we need to do, we need to use 2's complement. Why 2's complement? I told you, and I actually encourage you to find out why 2's complement is better than 1's complement. And there are a couple of reasons for that. For example, in 2's complement, we have only 1 zeros, but in 1's complement, we've got 2 zeros, which is not good. If I want to subtract two numbers, for example, like this, in 2's complement, what we do? First of all, we've got to flip the bits. Flip the bits. If you want to flip it, you get 1 and 0. Then you've got to add it by 1. You've got to flip the bits and add it by 1. Okay, how we can flip the bits in and actually using logical gate? What gate helps us to flip the bits? Yes, that's right. What we need to do, we need to use a NOT gate. If I use a NOT gate, it will flip the bits. So if I want to subtract two numbers, what I've got to do, I've got to only flip the second number and then add it by 1. How? I'll show you. Let's go back to this one. For example, for subtracting 4 bits number like this, for example, 1, 1, 0, 1 minus 0, 0, 1, 1. What I've got to do, if I want to do this, I've got to flip the second numbers, 1, 1, 0, 0. How I can flip them? Yes, what you need to do, this is A, this is B. For flipping the second number, you've got to put a NOT gate in front of B. So I will put a NOT gate here. So what I will do, I will make it a bit bigger to show you how I should act here. So what I need to do, to put a NOT gate there. If I put a NOT gate here, it will flip the bits for me. I do recommend you to use logically and see how it works. So now we can flip the bits if you want to subtract two numbers. But when you subtract, when you flip the bits, then you've got to add this by 1. So what we've got to do now in 2's complement, you have a, if you remember in the full adder, we have a carry in. So if you make it 1, job is done, because then it adds 1 to this number. It means that we can add this. Flip the second bit, add it by 1. So the carry in for the first one will be 1. In that case, this circuit, which is only called subtractor, will help us to subtract two numbers using 2's complement by only flipping the bits here and then add it by 1 as a carry in. So very good. And now we can both add number and subtract numbers. But this is not what happens in computer. We want to have a single circuit to be able to do both operations. We don't want to have two separate circuits. This one for subtracting, and where's the other one? And this one for adding 2 bits. Where is that? We don't want to have that. What we want to do, we want to have a single circuit to be able to do this operation. What we've got to do? Look, guys, what we need to do is to know that whether we are adding two numbers or subtracting. If I'm adding two numbers, if I'm adding A by B, addition. If I'm adding two numbers, I've got to, if, for example, whatever I have as B, I've got to flip it. If I'm subtracting them, let me write it here. If I'm subtracting them, I've got to flip it. But if I want to add them, I shouldn't make any changes to the B. Again, for adding two numbers, I don't need to make any changes to the second number. But if I'm subtracting them, I've got to flip them. How I can do that? Look, guys. Look at this. if I have two bits, two actually inputs, A and B, if I want to add them, if I say that when I want to add the first bit, or A is 0, if I want to subtract, the first bit is 1. Look, where is that? If I want to add them, again, if I want to add them, the first bit is 0. If I want to subtract them, the first bit is 1. 0. Look, guys, if I want to add them, that shouldn't change. 0 will stay 0. If I want to add them, the second number shouldn't change. 1 stays 1. But if I want to subtract them, the second number, B, should change. Look, if it is 1, I should change it to 1. If it is 1, the first one, I want to subtract them, the second bit should change. So what I wanted to say here is that if you want to add two numbers, that shouldn't change. If you want to subtract them, you've got to flip it. How? If I show that, if I use 0 to show the addition, if I use 1 for subtraction, I can have this table then. What is this gate, guys? This is an XOR gate. What it means? If I have A and if I have B, it depends on A to flip the second one or not. If it is 0 for positive numbers, I shouldn't change the B. B stays as it is. But if, let me use another color. If I want to subtract them, if I use 1 to show the subtraction, the second bit will be flipped. So it means that I will have, let's say B minus 1, I will flip the bit. So again, if I use XOR gate, I can do this operation. I can subtract them. What I mean, let me explain here. Look, guys, based on the concept that I just told you, if I put an XOR gate here in front of the second number, and if I have a switch out there, if I want to add them, the switch will be 0. I told you that for adding two numbers, the carry in will be 0. Nothing will change. But if I want to subtract them, the switch will be 1. Why? Because if this one is 1, the input to the XOR gate here, one of the inputs. If it is 1, definitely the second one will be flipped. Look, if the first input is 1, you should flip the second bit as XOR gate. So if you want to subtract that, if you turn it on, what happens? It will automatically flip the second number. That's perfect. It means that by using XOR gate, if I want to add them, if I turn this switch off, what happens? The first one is 0. It stays, B stays as it is. No change. Perfect for adding two numbers. But if I want to subtract them, if I turn it on, what it does, it flips the bits for the second one. That's perfect. This is for 2's complement. For 2's complement, you've got to flip the bits and add it by 1. Okay, this, when you are subtracting two numbers, it's 1. It acts as your carry in. So what happens, if we want to have a circuit to do both operations, what I need to do, I need to have such a structure. There you go. This structure works for both of them, adding and subtraction. If X is 0, it means I'm adding these two numbers. X is 0, adding two numbers, B stays as it is. But if I want to subtract them, this is for addition. If I want to subtract them, I turn it on. When you turn it on, it flips the bits. B minus 1. It will flip the bits, and also it has +1 for 2's complement. In that case, we can actually subtract two numbers. So this circuit is a unique circuit that we can use it for both addition and subtraction. I do recommend you to go through the worksheet, adder and subtractor, and please use logic gates to create all these circuits and test it whether it works or not. In the practical session that we will have, we will go through that again and we will create this circuit to show you how it works. Thank you very much, guys.